So what exactly is tabular data such that it requires an entire book to discuss, and why have deep learning techniques not been applied to them?
So I guess it really is. So if you're using pandas, like the Python library pandas to deal with, that's tabular data. So It has rows and columns.
Okay.
And deep learning, I guess you could see that there were some breakthrough moments dealing with image. So the ImageNet contest in 2012 was a real breakthrough for using deep learning with image. And then there have been some real breakthroughs using deep learning with unstructured text, so NLP.
Right.
But for tabular data, there really hasn't been an aha moment. Somebody say, well, this is something where it's been groundbreaking. And you compare a deep learning approach to a traditional machine learning approach, like using XGBoost, for example, or another tree-based model.
Sure.
And you look at Kaggle competitions, for example, which are sometimes used as sort of a benchmark for what the right approach to use is. And the fact is, XGBoost is the go-to approach in Kaggle competitions dealing with tabular data. But not all tabular data sets are the same. And a comparison made in 2017 between deep learning and we'll call them traditional machine learning approaches, you could see that the traditional approaches would be better because they're simpler, you get results faster, the performance would probably be better, and the deep learning had the frameworks were just difficult to use. So why do it the hard way when you could use a tree-based model and get results that are as good? Well, since 2017, the deep learning frameworks have gotten a lot more accessible. So you have fast.ai, for example. So fast.ai is built on top of PyTorch, and it's a great framework. It really gets, you literally with just half dozen lines of code, you can get a working deep learning model. And they've made tabular data a full citizen. So they talk about 4 types of data they deal with: visual data, collaborative filtering systems, text, and tabular data. So they have APIs specifically for tabular data, and you can get really, really decent results with tabular data using fast.ai. So it's sort of I think when the argument I make in the book is, it's not the idea that saying deep learning should be used for every tabular data problem. It's that deep learning shouldn't be excluded from the world of tabular data. There are particular data sets, particular problems where deep learning is worth a look. And because the platforms have become easier to use, that old objection to say, well, you could use an API in sklearn and it's just rather in scikit-learn, it's easier. Well, that's not really the case anymore. When you can get a decent deep learning application, for example, with fast.ai with just a few lines of code.
So is that mostly what was driving it? Just the APIs weren't there yet, and so it wasn't accessible, and there was just no real reason to build a deep learning model to handle these sorts of data sets when you could just do it more easily with XGBoost?
I think that was part of it. You can get good results with XGBoost. So if at the time, particularly 2016, 2017, deep learning was harder to do, then why not take the easier route? And I guess you don't have that lighthouse accomplishment to say, well, deep learning just blew away the competition,
right?
As was the case for vision data or audio or text. People were reluctant to use tabular data. Another thing I've seen is there are people in industry who are definitely using deep learning on tabular data, but it's all behind the firewall. So there are a lot of financial institutions, for example, that are using it, but that can't be put on you can't open source that. You certainly can't open source the data set because it's the company's crown jewels.
Right.
So I've talked to some folks who are doing work. This is the work they're doing on a daily basis, and they're a little bit frustrated because what they're doing doesn't get the attention that it could get if they could actually share the data set and be more open about what they're accomplishing.
So what are some of the kinds of tabular data that are especially amenable to processing with a deep learning model?
So I think one of the sweet spots is you quite often have a table where let's say you've got an online retailer and they've got a table for their that describes what they're selling. So you could have a code number for the article that's being sold, a size, a color, a price, and then a description. And the description is free-form text.